Hi everyone, Mr. McIntyre here. So this is Module 2, Section 2, and we're going to talk about solving one-step equations, which is actually pretty simple. It means one step and you're done. But what we're going to focus on is like the basics of equation solving in general. So as the equations get harder, you'll really understand the steps. So let's talk about equality. And I'm going to walk through a little activity here. I'm going to do it on the side here. But if you want, what you guys can do is grab a piece of scratch paper and do it with me with a different number and see that it works. So I said pick any number you want, so you can just choose any number. And I said use the reflexive property to write an equation. So for me, I'm going to choose the number 2. Now the reflexive property, if you remember from Module 1, says everything is equal to itself. So if I'm picking the number 2, my first equation is going to be 2 equals 2. And you say, yeah, that's true. It's a true statement. Of course it's true. Now, you guys maybe picked a different number. Maybe you picked 10 or even a negative number or fraction, whatever. You picked a different number from me. We're all going to add 6 to both sides of the equation. So I'm going to take my first side of the equation, the 2, and I'm going to put a plus 6 right here. Take the other side, I'm going to put a plus 6 right here. Now, 2 plus 6 is 8. And on the other side, 2 plus 6 is also 8. So you go, okay, that's true. 8 equals 8. So I added 6 to an equation and it stayed equal. Now let's multiply both sides of the equation by 4. So I'm going to do, in fact, let me get rid of that check mark there. I'm going to do this. I'm going to take my 8 and I'm going to multiply it by 4. I'm going to use that dot symbol for multiplying. Okay, now 4 times 8 is 32. And on the other side of the equation, 8 times 4, also 32. The equation's still equal. One last thing. Let's divide both sides of the equation by 2. So I'm going to use fractions for dividing. Instead of using divided by symbol, I'm going to use over 2 to mean divided by 2. So on the first side of the equation, 32 divided by 2 is 16. On the other side, 32 divided by 2 is 16. It stayed equal the whole time. Now the reason it stayed equal is because I was doing the same thing. If you start with two things that are equal, and you do the same thing to both of them, they're going to stay equal. Now if I only did it to one side, like if I just took one of these 16s and divided it by 2, my equation's not equal anymore. See, 16 divided by 2 is 8, and on the other side I have 16. 8 doesn't equal 16. It's not equal anymore because I did something to one side of the equation, but not to the other. So that's going to lead us to our two fundamental rules of equation solving. There are two main rules that you can use to solve absolutely any equation in math. Rule number 1, you can do anything you want to an equation, anything at all. You have complete freedom here. If you're solving an equation, you can do anything you want. You can multiply, divide, add, subtract. You can raise to an exponent, raise to a power. You can use a square root. As you get into more complicated functions later on in your math education, you can take the logarithm of both sides, anything you want. But the key is you have to do the same thing to both sides. Now the second key to solving equations is that inverses cancel each other out. And I said things like adding and subtracting, positive and negative. If I have a plus 3 and a minus 3, those cancel out, they're gone. Or multiplying and dividing. If I have times 10 and divided by 10, those cancel out, they're gone. And that's basically it. I mean, those two rules, just focusing on those two rules, you can solve any equation. So let's go back to solving the title of the section, solving a one-step equation. We're going to start with very easy equations just to get used to the process, and then each day we'll make the equations a little bit harder and a little bit harder. Now, the key to solving an equation is to what we call isolate the variable. If you want to solve for x, isolate x. If you want to solve for p, isolate p. And the word isolate means to get something all by itself. So if I want to solve for x, I want to get x all by itself on either side of the equation. It doesn't actually matter which side of the equal sign it's on, but as long as you get x all by itself, then whatever number is on the other side of the equal sign is the answer. And we're going to do that using inverse functions. And what we want to do is cancel out any numbers that are on the same side of the equal sign as the x. And if you cancel out those numbers, then you've isolated x and you've solved. So let's do a few examples. These are going to be nice and easy, because remember, this is one-step equation. So each one of these 3 examples we're going to do, we should do one thing and be done. So our first example, we want to solve for x. 7x equals 35. So I look at the equation and I go, okay, I see my x right here. That's what I want to isolate. Which means to isolate it, I need to get rid of the 7. So I say, well, I have 7x. What does that actually mean? That means multiply. 7x means 7 times x. Now to cancel out multiplying, you use dividing. So if I want to cancel out a times 7, I'm going to use a divided by 7. Now if I want to divide by 7, I can do that because I can do anything, but I have to do the same thing to both sides. So I'm going to do this. I'm going to divide both sides of the equation by 7. And remember, we use fractions to show divide. Now what happens is this. The multiply by 7 and the divide by 7 cancel each other out and just leave the x. See, we've isolated x now. Once you isolate x, it says x equals something, and whatever that something is the answer. So the answer to this question, we just need to simplify the other side. 35 divided by 7 is 5. And that's the answer to the question, x equals 5. So remember, you can do anything you want. In this case, what I wanted to do was divide by 7. I can do that as long as I remember to do the exact same thing on both sides of the equation. All right, let's try another one. This time we're going to solve for p, and we have 27 equals 4 plus p. So I go, all right, well, here's p right here. That's what I want to isolate, which means this time I need to get rid of that 4. So to cancel out the 4, I have 4 plus p, that's addition. To cancel out the p, that would be subtraction. That's a positive 4. Use opposites, basically. So to cancel out a plus 4 or a positive 4, I'm going to use a minus 4. But then remember the rule. If I want to do minus 4, I can do that, but I have to do it on both sides of the equal sign. So I'm going to do a minus 4 there on the right-hand side, and then I also do a minus 4. We'll just line it up under the 27 here. I did it. I subtracted 4 from both sides. That positive 4 minus 4 cancels. That's a 0, basically. My equal sign drops down. The p drops down. So again, I've basically solved for p. I isolated p. That means whatever number comes up on the other side of the equal sign is the answer. So on the other side, I have 24 minus 7. That would be 23. And remember I said earlier, it doesn't matter what side of the equal sign p is. This equation actually says 23 equals p, but that's the same as saying p equals 23. Remember, we called that the symmetric property in Module 1. So it doesn't matter which side p is or which side x is. As long as you get the variable by itself, the number on the other side of the equal sign is the answer. Let's do one last example here. This time we'll solve for z, and we have z over 8 equals 5. So remember, fractions mean divide. Z over 8 means z divided by 8. So if I want to isolate this z right here, which I do, to cancel out a divided by 8, I want to use times 8. I want to use multiply. So in order to cancel that out, I'm going to multiply it by 8. And then the rule is whatever you do to both sides. So if I'm going to multiply the left-hand side by 8, I also need to multiply this 5 by 8. Now the times 8 and the divided by 8 cancel, which leaves me with just the z, which means I got my answer. So the answer is 5 times 8, which is 40. So these are very simple equations. This is about as easy as equation solving can get because it's only one step. The title of the section was one-step equations. If you're doing these problems right, you're going to do one thing, you're going to cancel one thing, and what's left over will be the answer. And then as we move on through the chapter, we'll do two-step equations, we'll do multi-step equations. They'll get harder, but right now we're focusing on the fundamentals, the basics, to make sure we really understand the basics of equation solving before we start trying any harder ones.